in this context, a menu-driven program means that it's a console application like we've been writing that displays a list of choices. Press 1 to do this, press 2 to do that, press 3 to do this. So the menu is a list of choices on the screen, and then you can have, you know, some code that responds to the choice that was made. So as I recalled, we did a math program, right, that would print out, you know, x plus y, x minus y, and all that kind of stuff. We did that, right? Yeah. Okay, so we're going to write out a program that's going to have a method called menu, a function called menu. Doesn't have to do anything. It's not going to return anything. What's our menu going to do? It's going to display some choices. Press 1 to add 10. 2 to subtract 10. I'm going to try to make this look a little bit cleaner. Why does that give me an error? Well, I guess I'll just trust the force. 3 to divide by 10. And, oh, because we can't be using the plus sign, we have to be using the stream insertion operator. And -1 to exit. Okay, so that's our menu that we're going to be displaying. So our code is going to look like this. It's just going to be a big thing that says, while true, it's going to be an infinite loop. This is typically the easiest way to implement one of these. But we're going to display the menu. Then we're going to get their choice with a cin statement. Let's make a variable called choice. And then we will respond to that choice. With it, if you've ever heard of a case statement, switch statement, we could use switch case, but we haven't talked about that in this class, so we're just going to use if-else's. All right, so if the choice is equal to 1, we're going to add 10 to our number. Well, we don't have a number yet, so why don't we just make a number? Double x is equal to 0. We'll use double so that we can get fractional components. If choice is equal to 1, we're going to add 10 to it. X plus equals 10. Else, if choice is equal to 2, what do we do if we do a 2? According to our menu, which is now scrolled off the screen. What's 2 supposed to do?
Subtract.
Yeah, it subtracts. X minus equals 10, which, lest we forget, means x is equal to x minus 10. Else, if choice is equal to 3, we're going to divide by 10. X divided by 10. Else, if choice equals -1, we're going to break. I should have put that at the very top so it's really clear. I'm going to go do that. Right there. If choice is equal to -1, they wanted to quit. So break. The rest of these need to be else ifs. Else if choices, okay, then 3. We've done choices 1, 2, and 3 and -1. There aren't any more to do. However, what if they type in something that we don't know how to do? Or something unimplemented? We're going to see out, you know, invalid choice or unexpected choice. Okay, then we ought to go ahead and print our number out. See out value is now followed by the number that we're printing, you know, X. Okay, so we've written a menu-driven program. We display the menu. We get our choice using CIN. And then we respond to that choice with a series of if-else-ifs. Very common old school way of programming. You enter up a program that lists a bunch of things you can do. You can choose that thing. You can keep making choices. And when you're finally done, you know, you type in -1 or you hit escape or whatever the mechanism was for terminating the program. So here we go. I'm going to add 10 to it. Our value is 10. I'm going to add another 10 to it. I'm going to subtract 10. We're back down to 10. I'm going to add 10 again. Now we're up to 30. I'm going to divide by 10. 3. I'm going to add 10. Ooh, lucky 13. Add 10. Divide by 3. 2.3. And so on. We're finally tired of going, we're done. So really, you know, that's a pretty silly example, but you get the idea. Those choices could be more important, you know, more impactful. Like, you know, 1 to FTP file, you know, 2 to print file out, 3, you know, to delete file, you know, that kind of thing. I wanted to give an example because these things tend to only just, you know, mention this and then it rushes on to the next slide that has absolutely nothing to do with a menu-driven program. So the menu is a list of choices on the screen. You can implement them with if-else-if, or you can implement them with switch case statements. I'm going to demonstrate switch case even though it's not in this chapter. What you do, maybe I won't. Never mind. We'll hit it later. Okay, menu-driven program organization. Display a list of numbered or lettered choices for actions. Prompt the user to make the selection. Then test the user selection. If it's a match, then execute some code. If not, go to the next expression. Validating user input. That's when you check to see if it's validated or not. You know, what if they type in something that's not a correct age? Like, you know, the site is displaying risque material and it says enter your age and you type in -2. You're probably supposed to generate an error instead of just blindly letting them in because it didn't say it was between 0 and 17. You know, can perform various tests. You can check to make sure that the data is within a valid range. You can make sure that it's a valid menu choice, that they didn't type in 4 in my program. Yeah, I didn't demonstrate typing an invalid choice, but you know, we did put our else, our final else in there. So if I type 4, it just says invalid choice. Then later on, if I want to go add more choices, that's where I add them right here. Else if choice is equal to 4, else if choice is equal to 5, else if choice is equal to 6. And this is my final dangling else's. You can make sure you're not going to divide by 0. You know, if they type in, you know, and you're trying to do math and you divide by 0, then you'll kill your program. So input validation. Get the numeric test score. Enter your numeric test score. I will tell you the letter grade you've earned. So they do all of this. They make sure that it's above the minimum score and below the maximum score. Meaning, I guess, that the minimum score is probably a 0 and the maximum score is, you know, 100 or whatever you've decided the maximum score. So if they type in 1,000, it's going to print out that's an invalid score. Run the program again and do it right this time. Okay, so that's the idea of data validation, making sure the data is good. A lot of times, you know, nowadays when you're entering a new shipping address, the program does some validation on it to make sure that it is a valid shipping address. You know, and they're probably you know, using some web services that some other company has provided. The post office provides a service to where it'll generate the 9-digit zip code if you give it an address, but it's only a 5-digit zip code. But anyways, you know, you type in your address in Amazon and then it says, do you really mean this one? And it's more precise. You know, it's more precisely formatted. Well, that's a form of data validation. You might want to make sure that they're not typing in, you know, illegal characters, Unicode characters. You know, they're not trying to enter an Elvish name or, you know, something stupid like that. They're not trying to enter data that's 10,000 characters long in an effort to break the buffer of your program. They're not typing in letters where numbers are required. They're not typing in dates that are invalid. You know, please enter the birth date, and you type in 13/14/2055. No, you're not supposed to let them do that. So you would need to validate that to make sure that that's an actually a good date. And we don't really teach enough of that in these courses. You know, I could drill you on that data validation, you know, for a week or two. Comparing characters and strings. We've talked about ASCII values. ASCII has, the uppercase A has a value of 65. The lowercase a has a value that's 26 characters more than that, or maybe even more than that. So if you try to sort based on the ASCII value of that, all the uppercase letters are going to come before the lowercase letters. So if you were trying to sort your CD collection and some of them had been entered in uppercase and some of them had been entered in lowercase, it would look pretty goofy. Lowercase letters have higher ASCII codes than uppercase letters. So a lowercase a is greater than an uppercase z. So if you're trying to write a sort algorithm, you know, everything that starts with an uppercase letter is going to be listed up at the top, and then everything that starts with a lowercase letter is going to be shown underneath those. Get a character from the user. Enter a digit or a letter, and then we use cin.get to get a single character. We talked about that at least once. Determine what the user entered. If that character is greater than quote 0, they're comparing it to a quote now, a quoted number, a character, and is less than a 9, then we print you entered a digit. Else, if it's greater than a capital A and less than or equal to a capital Z, we say you've entered an uppercase letter. Else, if it's greater than a lowercase a and less than a lowercase z, you've entered a lowercase number. Else you say this is not a digit or a number. Well, that looks kind of fun. Why don't we do something like that? I'm going to call this one main menu. Let's create a new main method. Int main. Now, did they make it so I can just copy that text and paste it like good boys and girls, or no, they're going to make me type it? Thanks. Okay.
So we can't use it over and over?
Yeah. Alrighty. Cout. Can I type? Enter. Digit or letter. Go ahead and type this one in. We might have enough fun with this one to actually make it worthwhile doing it. We'll make a Dropbox for it. CH, well, it has to, we have to define it. Character, CH is equal to cin.get. If, let's print out the ASCII value of that character first. So turn that into an int first and just print it out, just because we're curious about it. Now let's do our if statements that they show there. If CH is greater than or equal to, and inside the quotes put a 0. That's not an O, it's a 0. And, which are 2 ampersands, shifts, not 7, yeah, shift 7. And CH is less than or equal to single quote 9. Then we're going to see out the word digit. Else if CH is greater than or equal to a capital A, and CH is less than or equal to, all right, I get enough of the idea here that I could just run with it. end all of your output with /n's, even though I didn't do that. I've since corrected it to do that. Excuse me, I have an error. I want to fix it before. Oh, main menu has to return a value. Fine. Alrighty. So that's what our program needs to look like. Of course, we need to include IO streams so that we get the CIN and the COut. We want to do using namespace so that we don't have to precede every CIN and COut with an STD : : Now it'd be really nice if this looped. So I'm going to enclose this entire body inside a while statement. While true, open brace. And I have to put a close brace down here at the end. That way I can do it over and over and over. I'm going to follow the convention of putting the opening curly brace after the while statement and after the main declaration, just so I can get more on the screen at one time. Something like that confusion. All right. Who was fast enough to type? Oh, and hit me syntax error.
John, do you want to just email it to me? Okay. I'll give you bacon
No, you want to subscribe?
made from people.
You know what I'm going to do is I'm going to post this in D2L because a lot of people didn't have Visual Studio working or it crashed. It was malfunctioning and stuff like that. So let me. All right, if you refresh your Dropbox, there's a in-class H. You'll find a Word document with this exact code in it. So I'm going to run it and demonstrate it to y'all. It says enter digit or letter. Well, first I'm going to type in a minus sign. Well, ASCII minus sign does not fall within any of the ranges we've checked. It does not fall between a lowercase a and an lowercase z, or an uppercase a and an uppercase z, or between a 0 and a 9. And that's because it's in a different section of the ASCII chart. We could pull up the ASCII chart and you'd see that. Now I'm going to do another one. How about 0? It knows that that is a character. Excuse me, that is a digit. So if we pull up the ASCII chart, we will see the values. I'm going to hide this over here, hide up our code for a minute, but you can always find it in our Dropbox. An uppercase A is a 65. An uppercase Z is a 90. So anywhere between 65 and 90, the value of the character is considered to be an uppercase letter. And what happens if you're entering, things with diacritical marks or little hearts and smiley faces and things like that? Well, that's totally not going to work with this. This is just pure, straight, old, boring English ASCII. So if you start trying to enter things with umlauts and stuff like that, it's not going to know it's a character. Lowercase a is at 97 and goes all the way out to 122. The numbers start at decimal value 48 and go all the way out to 57. And then you see these other ranges of symbols, like a space is 32, and all the way up to 47 are symbols. Other symbols, other punctuation. And then there's another little cluster of punctuation between 58 and 63. Why did they break it up there? I don't know. And then, let's come over here. Now, after 91, there's some more punctuation. Square braces and backslashes and stuff. And then the same thing's true over here. After the lowercase letters, there's some more punctuation. So ASCII is not really laid out I don't know, what I would consider logically, but I'm sure that they had a very good reason for doing it the way they did. So if you are doing sorts and you're using character data rather than, if you're using standard old ASCII characters that somebody typed in from the keyboard, it's not really going, I don't even know where I'm going with that statement. ASCII is totally inadequate for the task of holding data that might have, Roman character sets, umlauted O's. How could you spell Blue Oyster Cult if you can't put that umlaut over the O? Or Spinal Tap. So, but this is showing that what a character really is underneath the scene is it's just a number, the value. And some of those values correspond with the ASCII chart, but some of them do not. What happened if I type in something garbage like 003? Well, that's going to be a Control C. It prints out 3. Well, I don't know what that is. What about the 255? It decided that was a 10. I don't know why. What I'm doing is I'm holding the Alt key down and typing in some numbers. Y'all may have seen that trick. Like if you're in a web page or editing a Word document or something, you can type, page Alt 003, and it might put a little heart there, or 005 might be a musical symbol or stuff like that. I'm not managing to fool it, though, into accepting that into this output. So it takes a little bit of programming in order to get it so that it will sort uppercase A's and lowercase a's all in the same thing. Which would be a good thing, because if you're looking at your song list on Google Play or iTunes or something like that, you'd really like, all the names to be sorted regardless of whether the group started with an uppercase letter or a lowercase letter. So comparing string objects. Strings are compared the same way, except they just start at the first character, and then they go to the next character, and then they go to the next character, and then they go to the next character. So if you are comparing these two names, the way the computer does it behind the scenes, it's goes, okay, I'm gonna go out to the length of the name. M, okay, they're cool. A, okay, that's great. R, okay, that's cool. Cool. Y, K, oh, they differ. Well, which one is higher? A Y or a K? Y is later in the alphabet, so it's going to consider name 1 to be greater than name 2. So if you did if name 1 is greater than name 2, you'd print out true. If you print name 1 is less than name 2, it's going to print false because the Y is not less than a K. You know how it's ordered, just like if A was a 1 and B was a 2 and C was a 3, and Y was 25. I don't even know what this is supposed to be demonstrating. Determine and display the correct price. This looks like it just came out of nowhere. If part num is equal to S-29A, we print the price is, yeah, forget that, okay. The conditional operator, this is one of the weird things that you won't see very often. So I'm going to fill the next exam with it. No, I'm kidding. Totally kidding. But it's like a little teeny tiny if statement. And let me demonstrate what I mean by that. I'm going to write some code that uses an if statement, and I'm going to rewrite it using the conditional operator. Okay. X is equal to 3. No, let's actually use good old C out. Enter a number. And then we're going to read that into a number named X. Then we're going to do something based on that. If the number that they entered is equal to 100, we want to set, now we need a string. We're going to have a string named S. If X is equal to 100, our string is going to equal to the word right on the nose. Else, it's going to equal something else. Nope. Alrighty, that's how we would normally do this, right? But we can write this all in one line of code if we are so inclined to make our code more difficult to read. We would do this. S is equal to, and then you put some stuff in front of the conditional operator, which is a question mark. Is X equal to 100, question mark? You can do yourself a favor and put some of these things inside parentheses to make it look a little bit clearer. Is X equal to 100? If so, set S equal to right on the nose. Else, we use a colon as an else in this case, and this is looking totally alien. Else, set it equal to nope. This line of code does the same thing as these lines of code. Does that mean that it's better? No, it doesn't mean it's better. But it's called a conditional operator because the value of S is determined by this conditional, and if this is true, it equals the first thing before the colon. And if this is false, it equals the second thing, the thing after the colon.
Can I multiply a variable like an integer by a conditional operation?
Sure.
And then also by a S plus equals, the conditional operation, and then a number would only reassign it to that number if that condition is true.
That's sounding like you're trying to do more in a conditional statement than you want to. Like you're wanting to rewrite it if one condition is true, but not reassign it if another condition is true.
Yeah, basically doing the same thing as that, except for instead of using the question mark, simply multiplying the variable by that conditional operation. It's either going to be 0 or 1 multiplied by the actual operation.
Let's see if we can come up with something. Int y is equal to 1. Y is equal to y times,
Basically times false.
if
Either confirm or
if
deny.
x is equal to 0, then we want to multiply it by 0, else we want to multiply it by 1. Something like that.
That's not what I'm saying, but
Okay.
I'm saying like for instance, y equals y would plus equal y times x equals y, and then it would only maintain that value of y. It would only reassign that value if x equaled y. Otherwise, it would simply equal 0.
Okay, how about this? Y is equal to, and then you have your conditional here. If x is equal to y, then what do you want it to be set to if x is equal to y?
No, I'm asking. I apologize for being confusing. I'm basically asking if, let's say I wanted to, if I wanted to only assign the value of 2 to y if x was equal to y, I would simply say in parentheses x equals y and then multiply that by 2, and then none of the rest of that would be there at all. And I'm asking if I could do the same thing without any of the colons or question marks at all.
I'm not sure how to do that without the colons and the question marks. Here is how I would multiply y times 2 if x is equal to y with the conditional operator. Y is equal to, and if this is true, then y is going to be set to y times 2. Else y is going to just be set to its original value. Maybe that's close.
I'll run it on this computer. I'll tell you if what
Okay.
I'm saying works.
All right.
To you after class.
So yeah, you can make these things as hard to read as possible. You know, you could be brutal on the poor person who has to come in and maintain your code after you. This kind of stuff where you write if-else statements is much more lucid. This is much more compact. There's really no reason to do that unless you're pretty sure that the person who's coming after you is going to be able to, understand why you were doing that. It's not like this will operate any faster than this. So here's our example. Is x less than 0? Oh, wow. In C, you can do even weirder stuff than you can in Java. I forgot that you could actually include statements here. That kind of blows my mind. What if we did this then? Is x equal to 1? Sure, then C out. Oh yeah. Else C out. Oh no. That's pretty crazy. I have honestly never utilized that functionality of the code. I would break that up into an if-else statement. Well, I've broken it and it doesn't work. Oh, that's because I already had the window running. Kill it. Enter a number, 1. Oh yeah. Okay. Maybe you see why that works. I don't think conditional operators are the world's most important things to memorize, especially because the behavior of them varies considerably between variants of C, like C# and C++ and Java. I had no idea that you could actually embed a command like this as the second parameter and the third parameter there. This is also known as the ternary operator. Ternary meaning like, binary one takes 2 parts, the ternary takes 3 parts. What are the 3 parts? The first part is the part before the question mark. The second part is the part after the question mark but before the colon. And the third part is after the colon but before the semicolon. This is how I've seen it used usually. Some kind of conditional evaluation, to where if something is true, you're going to assign a value to that, else you're going to assign another value to that. Or in this case, if x is equal to y, we're going to multiply y by 2, else we're not. If I want you to know how to do that on the exam, I'll mention it again. I'm not going to assign anything where you have to do that. So the value of a conditional expression is the value of the second expression if the first expression is true, or it's equal to the third expression if the first expression is false. It says parentheses may be needed due to precedence of conditional operator. It's also just easier to read. If you put the condition in parentheses like I did here, then it's way easier to figure out what part of it comes before the question mark. All right, we're about at the end of this slide. The switch statement. All right, this is what I was talking about earlier. You can use a switch statement to replace a whole bunch of if-else-if statements sometimes. It makes a syntax that you may consider cleaner, easier to read. You may not consider it cleaner, easier to read. I'm going to rewrite that menu program that I wrote to use a switch statement. So here's what the main menu code looked like before I modified it. You know, we displayed the menu, we read their choice, and then we had if, else if, else if, else if. But now we're going to do something a little bit different. We're going to say switch on the variable choice. And if it's a -1, we want to break. That seems not to be working. Oh, I forgot. I put the colon in the wrong place. Okay. If it's a +1, we do whatever a +1 was supposed to do, which is add 10 to x. And then break. Actually, this is not going to work at all. This -1 business is not going to work at all in order for this to... I'm just going to remove that.
I didn't even put return 0 in it.
Yeah, if you did return 0, that would work. I'll put that in there. Okay, so if you type in a -1, we're going to return out of this code entirely. If it's a +1, x is equal to x plus 10. We break. That means you skip to the end of the switch statement, stop processing it. If case is equal to 2, if choice is equal to 2, we're going to subtract 10. X is equal to x minus 10. We're going to break. If the choice is equal to 3, then x is equal to x divided by 10. Break. And we are done. Which do you like better? Do you like this code with that word switch there and all these cases lining up real nice and neat? Or do you like this mess of if, else, ifs? Not that I'm trying to prejudice you with the words like mess and ghastly and things like that. But you may think that this looks cleaner once you get used to it. I would tend to agree. Anytime you have more than like 3 or 4 choices, I would consider strongly I would switch to switch. The way this works is you get down here, it hits the switch key, it compares the thing in the parentheses, which is going to be a variable, and it finds the matching value. So if choice is equal to -1, we return out of the method entirely. If choice is equal to +1, we add 10. If choice is equal to 2, we subtract 10. And if choice is equal to 3, we divide by 10. Same code, essentially, except putting a return here rather than a break. What's the purpose of these break statements? If I did not have these break statements, let me comment them out. At least comment one of them out.
Break is the function, right?
Not the break, it'll go to the next case.
It will fall through to the next case, exactly right. So it'll say the user typed in 1, so by the time we get here, choice is equal to 1. Switch on choice, okay, find the case that matches. Well, that's the case that matches. It's going to add 10 to it. Then it's going to fall through. Oh, and let's also subtract 10 from it. Then it finally does hit a break, and so it exits and goes down to the, the closing brace after the switch statement. So if you leave the break statements out, it falls through to the next case. Sometimes, rarely, that's actually what you want. But if that's true, you better document it so that's you in the future will remember why you did it like that. Fall through, put some comment there. Explain why it's a good idea to let it fall through and do both that and that. Because normally, these are supposed to be mutually exclusive options. You type in menu option 1, you only want it to do one thing. You don't want it to also do that thing and that thing. But that's why you have to have break statements. Here's their example. We're going to enter their grade. Enter A, B, or C. Oh, this is real brilliant. Case A, you entered an A. Case B, you entered a B. Case C, you entered a C. This is the world's most useless program except for the statement down here. You did not enter an A, B, or C. But you get the idea. The variable that you're going to make your choice that you're going to be acting upon goes inside the parentheses after the word switch. And then it just zips to whichever case matches that variable, the current state of that variable. If they typed in an A, it would print that out and hit break.
What's the limitation of the switch?
As in how many of them?
No, I know you can't do it for floating point numbers.
Yeah, you can't do them for floating point numbers, and you can't do ranges. What if you were trying to write that grade program where you wanted them to be able to enter grades 190 and that was an A? That doesn't work. You could get around that by dividing by 10, and so you'd only be checking by 10. A 10 or a 9 is an A, and an 8 is a B, and a 7 is a C. But anything that is a discrete byte integer type, like a character. Why am I saying that a character is an integer? It's because it's an integer that equals between 0 and 255, all the possible ASCII character values. Integers work there. Character works there. Strings probably do not. Let's write a little bit of code and see if we can get it to a switch on strings. Some languages, like Java, do support that. But they didn't when they first invented the language. That was something that they added on in a more recent version of Java. So I'm wondering if it's also been added on to C++. What am I looking at? Okay. So I'm going to write a little dummy switch statement, void dummy, parentheses. I'm going to make a string that contains S. In order to use string, I better include string up here, # include string. And it's equal to a word like fun. I'm going to try to switch on that string. Switch on S. And if S is equal to fun, we're going to print something out. Like, yay, I love fun. Fun is awesome. It's already given me underlines. I know this is not going to work. Just a second. Okay, pardon me? Okay. It's yelling at me because it says the expression must have an integral, and it's also got or enum, and we haven't talked about enums, type. An enum is just a way of creating a list of things that have numeric values, so that like green would be 1, and red would be 2, and orange would be 3, or something like that. So where a word can be hooked up with a numeric value. So in this language, you can only switch upon integer types, and character is considered an integer type.
Does it not always work for integers also? I wrote a program yesterday, it was just like a dice roll game,
Yeah?
and it did the math in there, but it would put the image into the app.
Oh,
And when I did if else's, it worked.
that's crazy. I don't know why it would be doing that if the data you were comparing actually was integers. If you wound up trying to compare a float to an integer, then it would give you an error. Did it compile and just not work, or would it not even compile?
Oh, it compiled and it worked. It just, like it did, I had to do the math and then I had to insert it, the corresponding die to the
Yeah.
number. And it did everything but put the images.
Weird.
What ID were you using?
Square.
Were you using a third-party library for display image? I wonder if it was in the library that you used it as display image.
I'd have to see the code and to toy with it, because I don't know why that would be the case. As long as you were doing integers, it should be the exact same thing as doing a switch statement. So, no good answer. Other languages have more flexibility in their switch statements. For example, Java, and I do believe Python as well, will let you switch on strings as well as on characters. So you could type this code in and it would work.
Python treats everything like a string down deep, I believe.
Yeah.
Is that right?
Yep. Switch statement requirements. Expression must be an integer variable or an expression that evaluates to an integer variable. What does that mean? Well, here, if this wasn't a variable, it might be a function call that returned an integer. You know, get choice, something like that. As long as get choice returned an integer, that would work. Or if it was something like this, if choice is equal to 0, question mark, make it 1, else make it 2. You know, something stupid like that. That still evaluates to be an integer. So that would still be a valid thing to switch upon. But there we're getting really nasty looking to read at. You know, the more complicated the code is to look at, yeah, the better you get at writing code, the easier it becomes to read it. But there's still, you know, levels of obfuscation that you don't want to try to.
So since bool is actually a 0 or 1, that should work.
Let's try it. Okay, Boolean B is equal to true. You ought to be able to do a switch on a bool by that definition. Switch B, case true, print true is awesome. Yeah, it's not giving me errors. This is working. Break. That's a really, really asinine way of writing an if statement. Case false. Okay. If you're as excited as I am to see this work, then you're weird. Okay. False is a bummer. All right. It's not giving me an error about that. That would compile and run, apparently. I'm not actually calling this method, so I can't prove that it'll work. And as a matter of fact, I'm getting an error. Oh, has to return something. Same idea though. We have a value stored in a variable. We're saying match this variable that's between the parentheses with the appropriate case. In this case, we have a Boolean variable and we're checking to see if it's true or false. You can see that that would be the same as writing this. If B, then do this, else do this. False is a bummer. So maybe by comparing those two things, you can see why I was kind of tickled to see this. It's just a really bad way of writing that. But it's cool. Alrighty, I'll stop geeking out. How it works, the expression is evaluated, and then the value of expression keeps getting evaluated through all the cases. If it ever matches one of them, it runs that code block inside that case. It continues until it hits a break statement. One thing I've left off is the default statement. Down in my code where I was handling the menu, I had an option that said invalid, menu choice. I don't have that in my switch statement up here, but I can put default here. Default. Cout. Invalid choice. And we could even print the choice out so that they know what it was. Okay, I want to actually see this code run, so I'm going to put it back as being main. All right, 1 to add 10, 2 to subtract 10. Let's first type in something that doesn't work at all, like 6. Invalid choice, 6. I have the code duplicated, unfortunately. I have both a switch statement followed by the if statements. I need to choose either one or the other, not do it both ways. So I'm going to delete the second batch. Okay, so here is our switch statement that handles that menu. After we get the user's choice, we execute our switch. If it matches any of these states, great, we execute the little code block that follows that case up until a return or a break is hit. If none of them match, then it finally bumps down to the default and it prints that out. Do you have to have a default? No, you don't, just like you don't have to have a final else on a series of if statements. But it's useful. Pretty much anytime you write a case statement, you may as well throw in a default case because it'll save you some heartache when you're trying to debug it and you can't figure out why your program isn't working. If it's printing out some kind of error message rather than just quietly not doing anything. And what do I mean by that? Without this default, we wouldn't get any indication that nothing had happened. I'm going to run it again and type in something that's going to not be one of our listed choices. I type in 4. It didn't do anything. It didn't change the value, but it didn't give us an error message to say it was incorrect. 1, it did add something to it. 2, if there was more feedback for the positive choices, but there was absolutely no feedback at all, if you typed in, an invalid choice, it'd be very puzzling for you. You'd be at one of those states where you're typing things in and nothing is happening. The break statement. We've seen the break statement before. The break statement will terminate a loop. I shouldn't say terminate a loop. It'll exit the loop, the innermost loop. Here I had a while statement going, and when I issued a break here, it zipped all the way to the end of the while loop and it left it. So it went down to the closing brace that matched the opening brace of the while loop. So I have an infinite loop, while true, but then when they typed in a -1, I issued a break. So it would keep scrolling down and find the closing brace that matched, the end of that code block. It would leave that code block and then it would be right here. A break statement here does the same thing. You hit break and it looks for the closing brace of the code block. All of this is a code block for the switch. So we hit brace, it's going to find the code block that, it's going to exit the code block that is subordinate to the switch statement. So it would run down here and it would print that out after that break happens. So, like you suggested, that's why I put a return statement there for -1. Because if I used break there, well, that just looks like all the other ones. Now when I type in a -1, it's not going to work. You know that lonely wind sound coming in from the hallway over there is kind of spooky. Alrighty, so, I type in -1, I want to exit. And it says, too bad, you have to do something. Okay, so I keep doing it. Ooh, that's cool. I typed in a non-numeric value, and it didn't know how to handle it. There are ways to fix that, but that's certainly not really what I wanted to see. Using switch in menu systems. The switch statement is a natural choice for menu-driven programs. You display the menu, you get their choice, and then you use that input as an expression in the switch statement. More about blocks and scope. The scope of a variable is the block in which it is defined, from the point of definition to the end of the block. And I know I've gotten up here and pretended I was looking through a telescope, So this variable right here, choice, its scope, its lifetime is from here all the way to the end of that code block. the end of the code block being the last brace, closing brace that marks the end of that while loop. After we leave this while loop, this variable doesn't exist anymore and its data is gone. It has fallen out of scope. It is no longer in scope. The only time that this variable can be accessed is while we are inside these braces that mark the code block in which it is defined. You can also get further in, like this variable called choice is still valid here and it's still valid here, and if you had a whole bunch of nested if statements, it'd be valid all the way there. But eventually, when you hit the closing brace that marks the end of the while loop, then it has fallen out of scope. It is no longer accessible. So you usually define your variables at the beginning of the function, or you can just define them willy-nilly, kind of up to you how you want to do it. A lot of people like to list all their variables up at the top of the function. Others people like to define them right when they're going to use them. The people who define them all up at the top have probably used a language where that was necessary at one time, like C.
In Python and JavaScript, one of those has no scope, everything is global, right? Is that JavaScript or was it Python?
It's certainly not Python. Python follows the rules pretty explicitly. I have forgotten whether JavaScript ignores scope or not. You could be very right about that.
The first coding I ever did was in JavaScript, and so then the second language I learned was Python. So that's why I can't remember is because I got used to simply assuming everything was global.
Right. Yeah. That's a good point. The word global scope. Anyways, variables are defined within a pair of braces are called local variables, or they have block scope. When inside a block within another block, you can redefine variables with the same name as the outer block, and I know I've demonstrated that. That's a bad idea. Just because you can do it, don't do it. Don't take advantage of the fact that when you're inside an inner block, you can redefine that variable. Like say, if they typed case is equal to 1, and I feel like redeclaring x right here, int x is equal to 3. I could do that. It's not going to give me an error, but it's stupid. There's no reason to do that. Because now, anywhere after this, if we change the value of x, we're only changing this one. And when we leave this code block, all those changes are lost. And that one maintains its original value. Other languages will flag that as an error. If you try to do that in Java, it flat out won't work. I'm curious about whether it'll work in Python. Forgive me.
Yes.
Define main. X is equal to 3. No, you don't define variables in
You don't have to
in
declare
Python.
the
You don't
data
give them a
type.
type, so there's no synonym.
It assumes if you give it like a prefix that follows the base, then it'll assume that it's an integer.
Yeah. All right, we are done with this chapter.
I have a question about scope.
Yes, sir.
When the variable's out of scope, does it release it from memory?
Depends on how groovy of a language you're using. If you're using something like Java, there's a garbage collector that will come along and free up objects.
Yeah, I know C++.
C++ doesn't really have a garbage collector. For simple data types, like simple primitives, like ints and floats and doubles, yeah, they are released. But if you've allocated a brand new object with the new keyword, or with alloc, A-L-L-O-C or something like that, then that memory will continue to be occupied unless you did something to free it. So that's what's known as a memory leak, and Firefox was notorious for this. You'd run your browser and you'd keep using it for a couple of days, and then you would check and your machine would say that Firefox is using 4 gigabytes of memory. And the reason why is because it was allocating memory and never releasing it. It was never freeing it. It was written in C++, which makes it easy to make that kind of mistake. Some of the other languages, like Python and Java, have what are known as garbage collectors, which will go out and free the data that was associated with variables that have fallen out of scope. And that makes them easier to use, but at the expense of maybe they run more slowly. And now there are ways of getting C++ to work that simulate the idea of the garbage collector. It doesn't really have one in it, but you can kind of simulate it. I don't think we're gonna get to the point where we're actually using those. Alrighty, gang, why don't we call it done? We've hit that. Are there any questions over what we have talked about? Did everybody get the little program working and uploaded into the Dropbox? If you type something in, you may as well upload it into H. I don't even care if it really works. 3 people have done so far. Everybody else upload something into the H folder. Upload anything. No, I'm kidding.
I have some special things in a special folder I can upload. About 4 gigabytes. Oh god. We'll upload the John boats. Did you want to see what I was asking about earlier?
Yeah.
I'll show you.
All right, so pretty much class is dismissed. You can bail, or you can hang out and talk, whichever you want.